Thank you very much, James and Pierre. Well, this concludes the SkyTalks session for this morning. What if we give a hearty round of applause for all of our speakers this morning? Thank you very much. So now we're ready for lunch. Whoa. Lunch today is sponsored by Gemalto, and to make the presentation on behalf of that company, we have James McLean. He is Director of Documents Readers Solution, and it's a pleasure to welcome you to the stage, James. Thank you. It's all yours. Thank you.
Thank you very much. Thank you for the opportunity to speak to you this morning. Which way? This way. So yeah, this morning I'd like to talk to you about document verification solutions and some of the technologies. Talk briefly about forged and counterfeit documents, and then get into some of the components and processes for document verification. So on the forged documents, as was mentioned earlier this morning, a forged document is when someone alters the data in a document. Typically they're altering the photo or some of the dates or names on the document. Counterfeiting is when they produce a look-alike, a complete imitation of the genuine document. Next, I have a few examples. These are some of the ones that we've come across working with our partners. It is not an editorial comment on the particular documents or that are there. These are criminal organizations will attempt to counterfeit or forge any document that's out there. So in this example, we have a document that was reported lost and stolen in March of 2014 in Turkey. Just a few weeks later, that same document was then used on a flight between Kuala Lumpur and Singapore. In that time, it had been altered with the photo was changed, as well as the gender, date of birth, place of birth were all modified. They didn't get the check digits correct in the MRZ. There was an error on the date of birth field as well as the overall check digit. And in this example, they actually mimicked a polycarbonate Datapage that they replaced. They didn't, the MRZ information didn't match, so that was quickly picked up. And as well, you'll see the UV images are completely different, where they were using a UV bright substrate and didn't even attempt to match the UV image. In this example, we have a document that was issued in 2013, which would be at the 2010 series passport. However, they were using a 2006 Datapage they'd gotten from a previous passport. And in this example, we have for image substitution, where they had attempted to mimic some of the holographic laminate. As you see on the left, we see the expected pattern, but the detected pattern is different, and that was picked up as an issue, as well as the UV was not correct. And in another example where we have where the chip and MRZ data failed to match the printed data failed to match what was in on the ePassport. We've also seen have reports of cases where forgers have been able to mimic ePassports, including all the cryptography. They don't have access to the country signing certificate, but all the other basic access control and other security features within the ePassport were mimicked and would have passed validation. Certainly, we have reports of like what we refer to as fantasy documents. These are not real countries, but people still do attempt to use these. In this example, we have actually a legitimate document that was lost, and the actual blank document was stolen. It was then personalized by the criminal organization, and it was detected via a query to Interpol's list of lost and stolen documents. And in this other example where we have it was a fraudulent use of a passport. So this is a legitimate passport, but by doing a biometric check between the person that was presenting the passport and the image, the printed image, and the image from the ePassport, they were identified as an impostor. So these are all just various examples of where criminal organizations attempt to forge documents and to use them, so, which emphasizes the need for having a strong document verification processes. So when we refer to document verification, I'm referring to a machine-assisted document verification, where it's to assist in screening and determining whether the document has been properly issued. There are some very key standards that are quite useful. The ICAO best practices for optical authentication is a very comprehensive guidelines for implementing machine-assisted document verification, as well as the other documents out there. So I'll just walk through some of the operations. So the first step is on the capturing of the data, so capturing the image. So in this example, you see a document that's at an angle. So that's all part of the actual capturing process to be able to crop the image and straighten it. I include in there the RF processing to be able to retrieve the expected data groups. Then the next step is around identifying the document to determine the document type, the issuing country, which particular generation. And the example I have on the bottom, it's in this case it's purportedly a Luxembourg ePassport, but at this point we're not very sure whether it is. So that's where we get into needing to do document verification, where we using the extracted data to do numerous verifications. That's on the MRZ, checking the document validity, looking at the various security features that are in the document. And included in this area that's very important is around verifying the ePassport information, doing all the cryptographic checks for an ePassport. And as well, it also is very useful to include a check for Interpol's lost and stolen documents, and where possible, a facial match, and automated to be able to match the person in front of who's presenting the document to the document itself, and followed by being able to report all the results. In addition to being able to capture with specialized hardware, there are also options to be able to do captures via mobile devices such as tablets and cell phones. These provide a lot more convenience. They certainly are able to operate in require less infrastructure. One of the things that we need to understand when implementing a mobile versus a specialized hardware is that the verification capabilities stop at the visible image. And an example I have here, a cell phone or tablet wouldn't be able to identify the UV features and use those for verification. And on the case here, be able to identify that the infrared image is not correct and validate the infrared features. This slide has some additional examples of some graphical features that we're able to check with document verification. Things such as matching a number printed in UV to the number printed in the MRZ zone, as well as looking for various security features in the document. Another important part of the overall solution is the template database, which includes reference templates for each of the documents that are out there. We have, and in that data, they would have reference images as well as all the verification and identification for those particular documents. And then the template administration tool, which needs to really be operated by a trained user who understands not only how the data structures work within a document verification solution, but also being able to do document forensics and understand those as well. And now I'll move on to some of the deployment options for document verification. And there's a wide variety of use cases, from automated gates and self-service kiosks, as we see organizations moving more towards using unmanned areas for the need for actually tying that crossing to a passport or credential. It becomes very important. We also see being used in border management systems and visa issuance situations, and a growing need actually on the commercial side in such areas, not just in airports for like currency exchange, but also financial institutions. The typical deployment option is around using a local installation where the document verification software and the templates are installed on a local PC or inside a gate or kiosk. And that works very well. Very well. It's high availability in a lot of ways because you have a self-contained solution. But we need to consider how the template management and template updates are done in this sort of deployment. So you would have a template, the database management, which typically would be done by your the vendor or the supplier of the document verification solution. And as new documents are issued or maybe adjustments need to be done to the thresholds and the verification checks. So these updates would then need to be pushed out, I guess, through the internet to the various countries or customers that are using the solution. If you've got a wide range of various locations and desktops and things, it is theoretically possible to push updates to them or have each workstation go out and query across the internet. There's a lot of security concerns around doing that. So we're seeing organizations moving to having an update server that is inside their organization, and then the updates going to each of the workstations or kiosks through that mechanism. Another deployment option is that is growing is around software as a service, where the document verification and the templates are hosted on a cloud system, a service. This can be either done either internal to a government or an IT organization, or it can actually also be external, by a service provider. In this deployment option, the templates updates are fairly easy to be managed because all the templates are stored centrally on the servers. And then the only thing that you really need on each of the workstations or kiosks is the image capture information. Another A growing option is around using network-based capture devices so that the document reader is able to use Ethernet or Wi-Fi to be able to capture the optical and ePassport information and send that to the host systems for document verification, where the results can then be pushed down to a tablet. And that frees up the border control officers, as opposed to being tied to a desk. They can be moving around more. They don't have to be assigned to a specific location. So in summary, there are still high quality forged documents are improving, that the criminal organizations are not, even as we produce, continue to produce increased security features, the criminal organizations are still trying to duplicate those or mimic those security features and to be able to counterfeit or forge documents. We're even seeing forgeries and counterfeits on the ePassport chips and those solutions, which necessitates a very strong document verification solution that not only looks at the optical features, but also the cryptographic features in an ePassport or EID, and can be augmented by the Interpol checks and biometric matching capability. And as mentioned, the specialized hardware provides opportunity for more detailed checks in an automated process. And then one of the other considerations when we're looking at these sort of solutions is around the flexibility of the deployment and the deployment options. So I'd like to thank you for your time. Are there any questions? All right.
Good. Okay. Thank you so much. Thank you.